Hey guys, welcome back to the channel. My name is Zahir, and I'm going to be talking about a very interesting concept, probably one of the best concepts that I have learned recently to build robust agents. And before I talk about that, I want to quickly run this example first. I want your kind attention in this particular folder. It's the to-dos folder. I'm going to run this particular agent now, or a LangGraph tool, or a LangGraph agent actually. And you will see that a file gets created. And let's see what that file is about. So I'm going to run this particular tool now, or I'm sorry, a LangGraph agent. And it's going to start in a few seconds. All right, the agent has started working and it has almost finished. Okay, so yeah, it has given me the resolution. Actually, this was a customer support agent. And the goal was to basically take in a query and return a response. Let me show you what that query looks like. The query is run a custom. I'm sorry. The query is I ordered a product 10 days ago, but haven't received it yet. Can I get a refund? And the ticket ID is this. And the idea here was to basically use LangGraph as an agent to generate a response. But the agent was written in such a way that it planned its entire operation to essentially come up with a resolution. That means the agent was able to generate several tasks or to-do lists and execute them one by one. What you're seeing on the screen is that to-do tool, write-todo tool. All right, with that established, I'm going to come back to this particular code base in a bit, but I want to talk about the most important bit, which is the write-to-dos list. I don't know if you can see this fully, but let me put this on full screen mode so that you can see this fully. Yeah. All right. As you can see on the screen, I have the three most prominent, agentic solutions. The two are from commercial vendors, Claude and Gemini CLI, and this one is an open source framework. And all of these are using this particular tool or pattern, whatever you want to call this. It's called a to-do list or write-to-dos. That's what most of them are calling today. And you can see that the definition of the write-to-do tool looks very similar in each of these agents. For example, LangChain calls it basically a tool that is used to maintain structured task lists. Gemini CLI has a similar definition. You can go through the definition in the tool, in the website. I'm going to share that link with you. And Claude, which I believe created this particular tool or concept first, uses something similar. I'm not sure, but I believe that it's Claude that created this. So let's try and understand what this is. And the reason I'm really excited about this is because all these major vendors, including Manus and including Cursor, are using this particular tool. It's called write-to-dos, which means that it is delivering, because we know that all these agents essentially run long running tasks, right? For example, Manus can build large applications can run for several hours. Same goes to Cursor, same goes to Claude Code. And all of these tools which run these long running processes need a way to manage the context, need a way to manage the tools and not deviate, manage the task and not deviate away from it. And this is where it comes in. So let me actually spend some time on what is the write-to-do tool. It's actually write-to-dos. So a write-to-do tool, essentially, it's like a powerful design pattern that most of the top tier agents share today. Essentially, it is used to create and manage to-do lists that help the agent stay organized and focused during long or complex tasks. If you look at the vendors like Manus or Cursor or Claude, they run for hours sometimes when they're creating large applications or large websites. They can run for hours. And to run for, when when you have an agent that is running for hours with and needs to keep in basically touch with the goal that it was given, you need a mechanism where it is fault tolerant. You need a mechanism where an agent can essentially fall back in it to check where it stands in terms of the goal and how it is progressing. So there are two parts to this, and I'm going to come back to that in a bit. For example, if you've used Claude Code, you probably have seen a feature called plan mode that essentially generates a list of steps before starting any work, and it basically dumps those steps into a tool called to do write. And each to-do list items essentially entails a description of what the task is and a status. I'm going to show you what that looks like in a bit. Same with Manus, right? Manus essentially deals with several tools, and to ensure that there is no context rot, meaning that it doesn't get overwhelmed with a lot of tools, it essentially creates this to-do list, and it helps. This particular to-do list helps Manus stay on track by consistently reminding the agents or sub-agents what is the goal, and it also reduces the risk of deviating from the actual task that was given to it, right? So there are two parts to this. The first one is planning. Here the agent receives a complex task and uses an LLM to decompose it into smaller actionable subtasks. You can think of this as the same implementation of the plan and execute agentic pattern, where you have this supervisor or a planner agent that essentially breaks down a task into subtasks and execute that, right? So what you're seeing on the screen is basically a query that comes from a customer, handle customer complaint about delayed order. So the agent's plan could look something like this. It is breaking down into search knowledge base, then look for similar past tickets, check the shipping status, and draft the response. So this is essentially allows clear instructions, very well defined steps that an agent can take to essentially accomplish a task, right? But the planning is not the only thing that is an agent does here. The most important part where the write to do list or the write to do tool comes is when the data is, that is the tasks or the to dos, are written into a file essentially. All these agents, the top tier agents, uses a file system, but it need not be a file system only. You can write this to maybe a KB store like Redis, so that you can read them much faster. Or you could essentially write that to a database, or you could use that in your agent state and keep that in memory. But the real value of using this is when you write it to a file, because you could use that file to essentially add as much context as possible while you're having this long the agent is executing these long tasks, or it has multi-turn conversations, or it is retrieving context from multiple sources. So the write to do tool can become, or the file that the write to do tool creates can become the place where it is essentially dumping a lot of context, and it becomes easy for the agent to access this particular context at will, instead of putting in a lot of context into its context window and essentially getting confused, if that made sense, right? Now let's move on to the next section, which is, I'm sorry, why use write to do's tool? The number one reason is transparency and debuggability, right? Here, when an agent essentially writes a plan to a file, it's not just the agent that will have access to it. You as a developer will have access to how the agent is essentially performing. And even the user that is actually using that particular agent can see what is the agent planning and how is it, essentially planning before executing, right? The reason number two is fault tolerance and recovery. Here, this is where it essentially gets really powerful. If your agent crashes halfway through a task, then essentially with with the right to do, you don't have to worry about losing everything. You can essentially continue where you left off. But imagine if you don't have this file-based to-do list, maybe you lose out. In fact, if you don't have this tool, you probably have to start over. You lose everything. And the last one is basically human in the loop workflows. Sometimes you want human approval before executing, right? For example, I might want to build an agent that basically gives a plan for every query that it gets, or if it is a long-running task or a research task, then what I would do first, or I'd like to have an agent that essentially creates a list of basically plans, uh, how it will essentially accomplish the task that was given to it. Let's say it's a research task. And as a user, I get to see that particular steps and I approve it. And then the agent essentially starts executing that particular plan and modify it wherever necessary, right? All right, let's move to the next section, when to use write-todos tool. I think the most common part is, the most common query type or a task type is essentially a multi-step task. It makes sense to use this if you have a task that needs to be broken down into multiple steps or parallel steps or multiple write-todos. For example, let's say that it's a research and analysis task. It makes sense to essentially break it down into multiple, or basically create a plan, right? You create multiple to-do lists and then you execute them one by one. The one example that we just saw in the beginning, a customer support workflow. Customer support workflow could entail essentially talking to multiple tools. So if a query comes in, we understand what the query is, or the agent understands what the query is and creates a step-by-step plan on how that particular query needs to be addressed, right? Data processing pipelines. I think the one usage where you will probably, which is with which this comes really handy and which is a perfect example of a long-running task, is code generation. Tools like Manus, Claude, Cursor use this write-todo tool to essentially, keep writing their plan and changing the status, reading the status wherever necessary, and amending it and adding as much context as possible to the write-todo tool, so that they don't deviate away from the actual goal of the task, right? Yeah, so some of the example. The next one is long-running operations. Anything that takes significant time benefits from fault tolerance and observability, as you know. Then the other one is high-stake operations. In high-stake operations, it makes absolute sense to essentially see, or the user having the ability to review an action before it is executed, right? Financial transactions, data deletion, product deployments. I would, as before an agent actually goes and execute it, I as a user would probably want to see what the agent would do and okay it, right? Obviously, if you see this, which also means that the it makes the or you want the agent to be collaborative, right? Where you want the human in the loop, and you want essentially the human to okay or give a go ahead and no go, depending on how the agent is performing or how the agent is essentially planning the task and executing it, right? When you should actually not be using it, or don't use the write-todos when it's a simple single task workflow. It doesn't make sense, right? Why complicate it with creating a file and dumping the to-do task? It doesn't make sense. If it's a simple question, like what is the weather like, or uh, you know, it doesn't require more than a single LLM call. to retrieve an answer, or maybe you don't even need an LLM call sometimes, you simply use, you don't use the write-todo tool, right? Same goes to the next one, which is basically you don't use this when you want real-time results. In fact, if you want real-time results, you probably have to write robust tools where you're solving for the workflows instead of calling multiple or allowing the agent to call tools in a loop. You should not be using this if you are expecting the answers to be quick, because this is going to take some time. As you can imagine, it will pan, it'll basically execute multiple steps. And if it is a small task, we go back to the point one here. You should not be using, if it's a simple single step task, you should not be using the write-todo tools, which I think most of the agent tasks are these days, right? The last one being stateless idempotent operations. What I mean by that is if the operation can be safely retried from scratch, the crash recovery benefit is less valuable. You don't, what I mean, essentially, if it's a task that you can simply retry, then why bother having a write-todo tool with all the context and list of steps? Though this is debatable, but I'd still say that if it's an idempotent operation, you should still not be using the write-todo tool. All right, with that established, let's actually look at the code base. I have already pushed this to the agent lab repo. I'm going to paste the link in the comment section. You can have a look at it. But let's actually look at how the agent was written. Let me quickly walk you through the agent. Yeah, this was the output. I'm going to come back to the output in a bit again, but let's look at the agent. All right, so this is essentially a LangGraph based agent. It has 3 nodes. As you can see, there is a plan node, execute node, and synthesize node. The plan basically sort of a planner agent, which essentially plans and creates a list of to-dos using an LLM, that is. We then use the execute tool to essentially execute the plan or the to-do that the previous node created. And the last one is synthesize. Basically, after all the executions are done, essentially the synthesize node creates a response for the user. Now, this essentially is, I would say, has the same implementation that of a React agent, but it's not a purely a React agent because it's not observing. We have not written that way, but this is still running in loop until a condition is met, which is basically if the synthesized condition, is met, it'll keep executing. Once the synthesized condition is met, the graph essentially ends there. All right, so that was the graph. I'm going to quickly show you the most important bits here, which is the to-do tool. The to-do tool is simple, essentially. If you look at it, it has 3 main operations. The first one being that the file is created the first time with the plan. The plan is essentially what an LLM generates the first time. That is the planner node. The plan node generates that, and we write that into a JSON file, essentially. That is our to-do list or the to-do tool. That's what writes it. The next one is we need to, at regular intervals or at regular stages in the loop that I just spoke about, between execute and synthesize, we need to keep reading the JSON, the to-do JSON, so that we see what step that needs to be executed, and we keep seeing the status as well, right? And the last bit is updating it. And at every turn or every iteration, we need to continuously update the to-do list so that every time we have executed one particular to do and we are moving on to the next one, we are updating the status. Okay. Now let me show you what a to do object looks like. You probably have seen that. Um, you've already seen that in the JSON that we just saw. But I'm going to quickly walk you through the planner node. The planner node is simple. It has a prompt, as you can see. Consider a step-by-step action plan, create a step-by-step action to resolve this issue. Each step should be specific and actionable. And I'm also telling it what it can do. I mean, search internal, the possible actions are a search internal knowledge base, look up recent similar ticket issues, check for product context, and blah, 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 blah. So I'm also giving it an example and passing the customer query, the original customer query that came in. And the to-do object looks something like this. It has an ID. It has a task. The task the LLM will generate for us. It has a status, and there is no result to it. But the idea is that when we are creating the task object for the first time, it starts with the status pending. And we write it to a JSON file that looks something like this. We capture the ticket ID, we add a timestamp, and we create the to-do file. Now I want to take you through the execute support action. Execute support action essentially, as you can see, we are using the support agent state. Support agent state, actually it's important you see the support agent state. Support agent state has ticket ID, customer query, the to-do file, the to-dos, that is a list of, it's a list of objects, but essentially it's a list of dictionary objects, but essentially that will have a to-do that looks something like this, the task, status, and so on and so forth. It also has the current to-do index to tell us which to-do that we are on currently in the iteration and what should we execute or what should the agent execute essentially. So let me go back to the execute tool now. So what we're trying to do here is we are trying to capture what is the current index, and based on that index, we simply capture the current to-do and we execute the current to-do. Here, obviously, I'm using a simple if-else condition to execute that, but in a real-world scenario or a production scenario, we will use the LLM to essentially, decide, or LLM with tool call to essentially, depending on the query or depending on the task, it'll call the relevant tool and return the response. So in this case, I'm just simulating with this with an if-else so that we can run this faster. To execute this, we have created stubbed to dummy methods that has stub data, as you can see here. This is stub data for specific scenarios like shipping, refund, etc., etc. And there is another one for searching knowledge base, which is essentially a list of key value pairs that we have created. I'm going to show you that in a bit. Okay. Now let me go back to the execute support section. Once one of the condition is met here, we simply update that write to do file, as you can see, and we update the status as complete. Should it be complete all the time? Not really. You can iterate here over and over again, and if the task is really complete, you then add complete. Otherwise, you mark that as pending and move on, or iterate again or retry that again. But this is just for simulation. So we assume that this particular, in this particular iteration, it has finished executing that particular to do. And as you can see, it has incremented that index again. And the state is still, the state is completed here, as you can see. But now let me go back to this part here. There is a check. If you remember, there is a conditional edge here. Let me show you the conditional edge again. The conditional edge should continue execution. Should continue execution actually looks at how many to-do items are left. If there are to-do items pending, then the conditional edge returns execute. And if there are no to-do list pending, then the conditional edge returns synthesize. Until then, the execute node is continuously run in a loop. So, for example, if the LLM generates 5 or 6 different tasks or subtasks or to-dos from the customer query, then the execute node will run 5 times and return this conditional edge will return synthesize after the 5th iteration. All right. The synthesize node is simple. It'll basically return a response as an email object to the customer. So that's all there is, guys. It's a simple one, as you can see. And you see how simple this is to implement and how useful this is when you're running a very large operation. Now imagine we saw a to-do of 5 items here, but let's say that you wanted an agent that would correct or amend the to-dos on the go as it basically iterates and as it captures context and changes the to-dos. So an operation could go from a few minutes to hours, right? A coding example is one such example. You now see how powerful this is. So it's very easy to write, as you can see. Oh yeah, let me show you the object as well. When I ran this, it was obviously this file didn't exist, but after running, this is what we have. So the LLM, let me show you the output as well here so that you can correlate the output. All right, so phase 1, planning and support actions. So the LLM actually created this plan. It has 4 to-dos: search knowledge base, look up the customer order, check recent similar tickets, review current refund processing. That's what we have. And in every iteration, this final object is after, obviously, what you're seeing is the output, the final object. But you see, we have the task, the status is completed. The result is no relevant article found in knowledge base. So it moved on to the next tasks. Look up the customer's order status in the system to determine if the product has shipped or if there were any delays. So it found 2 similar cases. It has written that, and it's seen what steps should the agent do or take depending on the context, the result it has found. So based on that, it checked the recent similar ticket issues to see if their customers are experiencing some similar delays. And it found that there are 2 similar tickets. And then the final thing is review current refund processing times to inform the customer about how long it may take. So it has captured all that information and then drafted a response. Obviously, the to-do will not have the response, but you could add the response as well if you want to add as much detail as possible. But we'll see the response at the end. We've just printed it. The response, that is the synthesized node, has written this. Thank you for reaching out regarding your order. I understand you placed your order 10 days ago and have not yet received it. Upon checking, I found that the similar cases have occurred recently, often due to shipping delays. So this was after all the context that it captured, and it has returned this particular response. So a simple one-line query was broken down into multiple tasks, and the agent was able to capture as much information as possible, and then essentially draft a response that looks something like this. Now imagine the latency here could be even lesser if most of the tasks it could be parallel, or if the tasks had dependency. For example, if the current task has a dependency on the previous task, then you arrange those as sequential steps. But you get what I'm trying to say here, right? So this is a very powerful tool. Let me go back to the PPT again. This is one of the most powerful recent patterns that I've seen, and it is being used by all these top-tier, world-class agentic systems. And I definitely recommend you go and implement this. LangChain has a very good implementation. I definitely recommend you start there and see how they implement it so that you can use that in your systems. All right, guys, that's all I had today. If you like this video, please subscribe and share it with your friends. And until next time, you guys take care. Thank you.